Hello, I'm Fernando Mercês from Trend Micro's FTR team, and I'm going to talk about analyzing data from HWP files. First of all, HWP files are used by a software called Hangul Office, that is basically the Korean version of Microsoft Office suite-like. So it's basically a container for a document. But in fact, what we see if we analyze one of these HWP files, TRD is actually able to correctly detect that is a HWP file used by your Hangul Office word processor, and also it detects this as a generic OLA2. It's a compound file, which is basically a format that can store different files and also streams and also directories. So basically, to extract valuable information from this kind of file, I use this software called Cerbero. It has this interface. So basically, in this here in the left side, we have all the streams, all the structures that are inside this file. And one of the most interesting ones to see if a file is malicious, that look malicious, is the default JavaScript, which is basically it can contain JavaScript code, which is not the case of this, given the size. The just a few bytes are in this section. But there is also an EPS file here. Well, most of these streams are actually compressed by zlib. So what we will have to do first is to uncompress it. And if we push Ctrl A, right click and apply a filter over it, we can see that there is a set of default filters that we can apply using this profiler. And well, zlib is the first one under unpack folder, is the first one that I'm going to apply in this stream. Here is the stream, but as I said, it's compressed. We have to check this raw checkbox and then apply the filter and then click on preview. Then we have the uncompressed stream here on the right side. And what I'm looking for is anything that look malicious within this document. So in this stream that's called bin data, there is a EPS file that is compressed, and when you uncompress that using zlib, so we get this stream of bytes. If you see this, if you look at over these bytes, they have a weird pattern, which is basically a NOP sled, even though it's before instead of 90. This SOAP code is also used by exploits for doing basically nothing. And we also can detect here that there is something that may be an obsolete using the original 90, and then E8 and other bytes here that may be a call. So what we do here, we have to isolate those bytes, right? So I'm going to start from the E8, which is this, and then we save the position, which is 1F042. Then I'm going to select all of this to select all of those bytes, and see we reach the end of this. Apparently it's a payload. So that's one way of extracting this information. So it ends here. So we have the size, it's FDC. So this is the size, the total size of the bytes, that the amount of bytes that we selected. And the position, it starts in 1F042. With this, we can apply. There's actually a different techniques that we can use here, but one of them is applying another filter, which happens to be the copy one, and then we can set it to start at the offset 1F042. So we're gonna start at the beginning of our selection. The size, we copy FDC as well, and then we set this trim for both sides. So we're gonna remove the bytes on the left and also the bytes on the right. Again, preview. Nice. So we have only the bytes here that look like a payload. So now you may have noticed that the bytes are actually in their ASCII representation, right? Because this is a EPS exploit file that uses that as that's just the payload that will be loaded in RAM later on. So what we have to do here is to convert from hex, and then we're gonna have these bytes actually in binary format, not the ASCII values for them. Done. So now we have the E800, so exactly the bytes that were in the ASCII column, they are now in the binary format. And then finally, of course, we can Ctrl A, select all of those bytes and copy into a new file, so we can save that and use any disassembler that we like, that we want to actually inspect this code. But Cerberus also has a basic disassembler here that can at least give us an idea of what this code is doing. So that's it. So we have basically a very familiar routine of starting an exploit code, calling the next address, and so on. So, and from that, of course, for this specific file, we have to see when it's injected in a process. But for this video, I wanted to focus on how to extract data, actual data from this kind of file using this tool. Of course, you can use different tools, but this one is one of the good ones that has a lot of filters already inside. And in this case, we used like 4 filters, right? And by correctly using and combining them, because they work like in a way where one filter is applied over another. So this is a very interesting way of seeing data. That's it. I hope you enjoyed, and if you do, please subscribe to our channel, like the video, so you feel motivated to publish new ones. See you there.